Hi everyone. In this video I am going to explain about encoder. Encoder is a digital circuit which is a combinational logic device. Encoder is a combinational logic circuit. In the beginning I told you there are two different types of logic circuits, sequential logic circuits and combinational logic circuits. When there is no memory, such type of circuits come under this combinational logic circuits. Okay, so encoder, decoder, multiplexer, demultiplexer, all such devices come under combinational logic devices as they don't have any memory devices. Okay, so encoder is simply an example of combinational logic circuit, and it is having multiple input, multiple output. So it has multiple input and multiple output and multiple output. So basically if you say we have already studied decoder, so it is an opposite action of the decoder. Encoder is nothing but an opposite action of decoder. Encoder is an opposite action of decoder. Encoder is an opposite action of the decoder. That means how many inputs and how many outputs that we can expect from this encoder. As we have seen, decoder has n inputs and 2 power n output lines. Encoder will convert in the reverse order. That means it has 2 power n input lines, 2 power n input lines and n output lines. Okay, so that's why the size of this encoder is 2 power n by n. Generally speaking, the size of encoder is 2 power n by n. Okay, so this is what the encoder introduction, 2 power n input lines and n output lines. So generally speaking, if you are having an encoder like this, so encoder 2 power n by n, 2 power n input lines, 2 power n input lines and n output lines, n output lines. And it is having along with this one enable pin. Enable pin is always there for all the ICs to enable whenever we need, otherwise it will be in the disable state. Okay, so the main application of this encoder, decoder and multiplexers are in the communication. Main application is in the communication field, because when we are sending a 16-bit data from one place to another place, then we need to encode that data into a limited version like a 4-bit. Suppose for example, we have 16-bit data which can be written as 2 power 4. We have 16-bit data which can be written as 2 power 4. So this 2 power 4 data, when we are transmitting from one point to another point, during this transmission, this 2 power 4 bit data is going to be encoded, So here we have encoder, and this encoder will produce only 4 bit of information. This 4 bit of information will be transmitted to the other end. This is what encoded information. So this encoded data, if anybody hacks inside during transmission, if anybody hacks this, they cannot understand what is the original data. Okay, the receiver, after receiving, they first keep a decoder. This decoder takes a 4 bit of information and decodes into 16 bits of data, because decoder is the opposite action of the encoder. Okay, so what is the mechanism that encoder has used to encode a 2 power 4 bit data into 4 bit? The decoder and receiver only knows these two mechanisms. Mechanism used to encode the data will be known by the receiver. Receiver will do the decoding and transmitter will do the encoding, so that the information can be easily and safely transmitted from one point to another point. This is the main application of the encoder, decoders, and multiplexer is nothing but, suppose if you are having such n number of encoders and if you are having such n number of decoders, all this information from all the encoders, n number of encoders, can be transmitted into a single channel. That is what the multiplexing. So all the information as grouped, and that means parallel to serial and serial to parallel conversion going to be done using multiplexers. Okay, so the main applications we can find in the communication field. This is what the encoder application. Okay, now let us consider a 4 to 2 encoder. Consider the let n is equal to 2. Let n is equal to 2. So as n is equal to 2, the size of encoder is 4 by 2. The size of encoder is 4 by 2. So now we are going to study 4 by 2 encoder. 4 by 2 encoder. So what is the logic diagram of the 4 by 2 encoder? So the symbol is, it is having four input lines and one and two outputs. Okay, if you want to keep enable pin, that you can keep, otherwise, but just for example, you no need to consider. So it is having four inputs: I3, I2, I0, I1, and Y1, Y0. Okay, so these are the two outputs and these are the four inputs. It is having 4 to 2 size. Now coming to the truth table, see, once if you understand whether it is an encoder or decoder, one concept if you understand, the other is very easy. Okay, so the inputs are I3, I2, I1, I0. Always better, you better write from MSB to LSB, and Y1, Y0, because when you are representing the number in a binary format, it is always better to represent MSB to LSB. Now consider 0 0 0 1. That means I0 pin is 1 now. I0 pin is 1, nothing but this pin is activated and remaining all are zeros. So whichever pin is activated, the corresponding binary data will be coming as output. So as it is 0, the 0 corresponding binary data is 0 0. Now 0 0 1 0. 0 0 1 0, which pin is activated now? First pin. So what is the binary equivalent of 1 0 1? This is the output. See, if you consider Y0 Y1, then there is a problem in the representation. Again, you have to check properly. If you take Y0 Y1, then 0 0 1 0 will come. Okay, that's why always better to consider MSB to LSB. MSB to LSB, that is always better. Okay, and 0 1 0 0 0 1 0 0 1 means the second bit. Second means the equivalent binary representation is 1 0, and similarly the last one 1 0 0. So third means 1 1. Okay, so this is the truth table representation. If you understand the concept, you can simply go for the higher order also. Okay, how can you write the Boolean expression from this case? When y1 becomes 1, so the Boolean expressions we can write it as Boolean expression from truth tables. Boolean expressions will be, see, y1 is equal to and y0 is equal to. So y1 y0, if you go to the truth table, y0 is having 1 here and here. So y0 has 1 in I1 case and as well as in I3 case. So we can write y0 as I3 plus when I1. That means if any one of the inputs I1 and I3 becomes 1, then y0 is equal to 1. This is an OR operation. This plus indicates an OR operation. And similarly, take this color. Y1 is 1 here, here. Y1 is 1 in these two cases. Here and here. So when these two cases are occurring, when I1 is 1 and I3 is 1. So we can write it as I3 plus I2. I2 is 1 and I3 is 1. That means if any of these two, either I2 or I3 becomes 1, then the output Y1 becomes 1. Okay, it is also an OR operation between these two. So simply we can write, we can draw the logic circuit, internal circuit for this 422 encoder is. So logic circuit. So we have I3, I2, sorry, I2. How many inputs are there? 4 inputs are there, but I0 is not involved. So just simply take I3, I2, I1. I3, I2, I1. So 2 OR gates. So first target Y1, 3, 2, Y1, and this is Y0, I3 and I2. And second Y0 is I3, I1. I3, I1. Okay. If you want to take I0, you can also take, but I0 is nowhere connected, nowhere related to the output. Okay. This is what the logic circuit of the 422 encoder. Okay. So in the next class, I will tell you how to write the VHDL code for this 422 encoder. Thank you.